I'm Anil Kumar. Welcome to my series on trigonometry. We'll understand transformation of basic trigonometric function and then answer this question where we need to find what is period, amplitude, maximum and minimum and the equation of principal axis for the given trigonometric equations. You can always pause the video, answer this question and then look into my suggestions. Now, before filling up this table, I'll take up the very basic concept and then we'll get back to the question. So let us first discuss some key features which a trigonometric function like y equals to a sine kx plus c could represent. So we'll discuss what is, when I say the equation is y equals to a sine of kx plus c. In that case, what does this represent? Let us assume that all these values are positive, right? So in that case, on a graph, we could represent in the following fashion. C is the principal axis. So the value of C you could draw like this. A horizontal line, y equals to c, and this is called the principal axis, right? So we call this as principal axis. Now, a is basically the amplitude of a sine function. So a is amplitude. A is also a distance from principal axis. Both in positive direction and negative. So let us say the value of A is so much, right? Let's say this much, right? So the maximum will be so many units above the principal axis and the minimum will be those many units below the principal axis. You get the point, right? So that is the emphasis of A. So we could say the amplitude A is the distance from principal axis, right? So it is absolute A which is we are talking about, right? The value k defines the number of waves within 360, or k is basically number of waves in 360 degree, or you can say 2 pi radius. The other way to look into k is it is related with time period. So k defines time period, which is 360 degrees divided by k. So time period is 360 degrees divided by k. Okay. So if I have to sketch a sine function with the given parameters, I could easily do from these things. We're talking about sine function. It will be kind of like this. Now if I've sketched a sine function like this, that really means that one particular wave, this is one cycle, right? So I've sketched one cycle. The distance from here to there is 360 degrees divided by k. That is the distance. Correct? And these things are equally spaced. What I'm trying to say is that these are like 4 quadrants. Correct? So if the total time period is t, then this point will be at t by 2. This will be at t by 4. And this will be 1t by 4, 2t by 4. This is 3t by 4, that point. And that is 2t. 4t by 4, which is t. Right? So that is how your graph is going to be. So I hope you clearly understand how y equals to a sine kx plus c can be sketched, and how all these parameters are related with the key features, which are amplitude is a, principal axis is c, k defines the time period, 360 divided by k, right? That is t. Now from here, you can also find domain and range, right? Domain, we are saying one time period. Let me write down range also here. Range will be from minimum to maximum, right? Minimum to maximum, correct? So that will be the range. Now you see, the minimum value is always x's minus a, right? So the minimum value here, which you see this point, is c minus a. That is the minimum value. And c plus a is the maximum value. Do you see that? So that is what maximum and minimum are. So if from the equation we have to find what is minimum and what is maximum, we can write like this. We can write as minimum is equal to c minus a, and maximum is equal to c plus a. Is that clear to you? Now all the information on this is what you need to know to answer the question which we began with. Perfect. So now we'll answer this particular question. For different equations or functions, we'll find what period is, what amplitude is, what is the maximum value, what is the minimum value, and the axis. Correct? So remember what we just discussed. That is, we discussed the equation y equals to a sine kx plus c. Is it okay? So this is what we discussed. So if I have to calculate the period, what will I do? I will divide 360 degrees by k, correct? If I have to say what is amplitude, it is directly the value of a. The maximum value is x's plus a, so it is c plus a. Minimum is c minus a, and the axis is a, right? So these are the values which will help you to fill this particular table. Is that clear to you? Perfect. Now let's take one by one and answer. Now default value for a is 1, right? If there's nothing here, it means 1. For example, a is 1 here, right? So let's begin with sine 3x. So sine 3x period will be how much? 360 divided by 3, which is 120 degrees. Amplitude is 1. Axis, c value is 0, right? It is the x-axis. So when you add 1 to it, you get a maximum value. Minimum is minus 1. So those are the values of period, amplitude, maximum, minimum, and axis for sine 3x. Is that clear to you? Now let's look into 3 cos half x. Well, sine and cosine are similar functions, so it doesn't really change, right? Except for at 0 you will have maximum, not 0. Okay, but that will not affect period, amplitude, maximum, minimum, and axis. So these things remain the same. So 3 is the amplitude, right? So we can write now 3 for amplitude. C is not there, so I'm writing 0 for axis. Half. Half means we'll now divide 360 by half. So what do we get? We get 720 degrees. So that is the period now. Is that clear? Maximum and minimum, add these two, right? And then subtract. So we get minus 3. Is that clear to you? Perfect. Now look here. We have got 1 minus 3 sine 0.1x. So this 1 is actually c. So we'll put this in c, right? Minus 3. Amplitude is always positive, right? So this will go, 3 will go here in amplitude. Note, amplitude is always positive. Is it okay? So it doesn't matter if I write negative here. The function may go first down and then up. First negative, then up. Positive, right? However, amplitude will be positive. Okay. Now, how do we find the period? 0.1. So this time, I'm going to divide 360 by 0.1. That is 3600, right? So, time period now will be 3600. We're talking about degrees. Okay. Now, to get the maximum value, I have to add 1 and 3. We get 4. And to get the minimum value, 1 minus 3. So we get minus 2. Is that clear to you? Perfect. In this case, minus 2 is the axis. Sign matters here. So let me write first minus 2, right? 0.75 is the amplitude. It is the positive value. 0.75. Clear? 6. So we'll divide 360 by 6. That gives us 60 degrees. That is going to be the time period. As far as the maximum minimum values, we'll add these, right? So when you add plus 0.75 to minus 2, what do you get? You get minus 1.25, correct? That is your maximum. And the minimum will be minus 2.75. The next one here is half cos half x plus 5. Now 5 is your axis, correct? And half is your amplitude. Directly you could read these values. That is why I'm writing them first. For the other things, we have to do calculation, right? Once you get this, you can calculate these two, right? So if you add half to 5, you get the maximum. So which is 5.5 or 5.5. And if you take away half, you get what? 4.5, right? So 4.5 will be the minimum. As far as the time period is concerned, it will be, just as we did here, 720. That is 360 divided by half, which is 720 degrees. Do you see that? So that is how we are going to find period, amplitude, maximum, minimum, and the axis for any trigonometric sinusoidal function, right? So as a practice, I can give you one question. You can now do y equals to 3 by 4 sine of, let's say 72x, right? 72x minus 1. So I'd like you to find all these values for the given function. But I hope in general you understand how, given a sinusoidal function, how do we find period, amplitude, maximum, minimum, axis, right? And knowing these values, you could sketch your graph just as we did earlier. Perfect. So this forms the base of all those questions which we are talking about. I hope that helps. Feel free to write your comment, share your views, and if you like, subscribe to my videos. That'd be great. Thanks for watching and all the best.